Hi everyone, my name is Jack Phillips. I am a graduating senior in the Environmental Studies program here at UCSB, and my Eli project is called the Grown Surfboard. Starting off with a little roadmap of the presentation, I am going to begin with an introduction to my project. Then I'm going to move into exactly what I did and what I accomplished, followed by my vision for the future of the project, and finally, a leadership reflection before I sign off. So starting with the problem, surfboards. There's a fundamental disconnect in the surf community. Surfers stand for the conservation of our coasts, but the surfboards that we ride are made of petroleum-based plastics that never decompose and directly contribute to microplastic pollution on our coasts. More than 400,000 surfboards are produced annually, with around 40% of input materials being discarded as waste. The carbon footprint of a single surfboard is around 200 kilograms of carbon dioxide equivalent. When you apply this number to the low end estimate of 400,000 surfboards per year, that's 80 million kilograms of carbon dioxide equivalent or greenhouse gas emissions per year. So my goal was to redesign the surfboard from the ground up utilizing mycelium composite. And mycelium composite refers to a biomaterial that is composed of an organic substrate, in this case, agricultural waste, that has been colonized by a species of mushroom-producing fungi and then dried, which produces a material with similar characteristics to plastic-based foams. This is the SMART goal that I used to get specific about my project and set out guidelines and milestones in order to measure success throughout my time working in Eli, which leads me to what I actually did. So during fall quarter, I started with a background research phase. I was paired with my mentor, Valeria, who is a aerospace and mechanical engineering professor at UC Davis. I also conducted over 10 informational interviews with professionals in related fields and read over 20 different scientific articles and white papers on these materials and their production. Moving into winter quarter, I started a small scale prototyping phase. So during this phase, I learned to grow the material itself. I learned that it's very sensitive to mold contamination in early stages of growth, which is why I tried my best to use sterile technique. After I learned to grow it, I tested dry material by shaping small prototypes, and this was done as a sort of strength integrity test. And finally, I tested um, the ability of the material to bind to classic and bio-based epoxy resin as well as fiberglass. And in spring quarter, I spent my time trying to scale up from the small parts that you saw before to a full scale 5'5" by 21-inch surfboard blank. And so I started by sourcing scrap cardboard from Costco and upcycling it to the dimensions of the mold that I needed. I then ground up 42 pounds of mycelium material and added it to that mold. I then capped the mold in order to preserve humidity and incubated it for around a week before pulling out these samples to dry for around another week, which leaves me with what you see on the right, a full-sized surfboard blank made out of mushrooms. And that leads me to where I am currently. So the project is still in progress. Unfortunately, I lost 1/3 of the material that I intended to use on the final prototype to mold contamination. That being said, I have replacement material on the way, and when that gets here, I'm going to add more volume to the board, which increases the strength of what I currently have, and then I will laminate it using uh, reliably and responsibly sourced hemp cloth in place of fiberglass and bioresin as well. Moving on to outcomes and accomplishments, comparing my grown surfboard to a traditional one is actually quite exciting. Once completed, the surfboard that I grew will have less than one half of the carbon impact of a traditionally manufactured one. Um, to add on to this, the blank or the core of the surfboard is completely biodegradable and non-toxic, which means that um, the waste from shaping is also non-harmful to the environment. And finally, the carbon footprint of the surfboard itself is resultant exclusively of the bioresin that I used. As far as applicability goes, this material shows promise in the area of environmentally friendly or sustainable surfboards. Local shapers that I interviewed were excited to hear about my project, and I conducted a survey of UCSB students with 100% of respondents saying that they would ride an eco-friendly surfboard, and 73% saying that they would choose an environmentally or reduced environmental impact surfboard over a traditionally manufactured one due to that simple fact of eco-consciousness alone. There are some challenges, however. Weight is a issue when talking about surfboard performance, and this material weighs slightly more than plastic-based foams. The material is actually alive while it grows, and that being said, it will grow inconsistently, and no two surfboards grown using mycelium composite will ever be exactly identical. And finally, workflows between building a surfboard like this and a traditional one are very different, which pose obstacles to integration by current surfboard shapers. And nearing the end now, the future of the project. I look forward to continuing to learn about this material. I want to continue to work with my current mentors in order to streamline the R&D process. I want to use tools that allow me to be more precise as well as reusable tools which cut down on uh, input materials that I have to use in order to test different boards. I also want to test different substrates and species, looking for different material properties that might be better for the application that I am trying to use it for. And finally, I'm in search of a natural resin alternative in the pursuit of a net carbon zero final product. And I'm going to end on a leadership reflection. I've grown a lot as a leader during my time as an Eli student. This project was entirely self-led, and I learned the importance of time management, goal making, and expectation setting, as well as a growth mindset when working on self-led projects, and how much that really matters when working on keeping motivation throughout the year. I also learned to believe in the process when I faced many moments of doubt throughout my time working on this project. And finally, I wanted to thank you for watching. I want to thank Erica, my program director, and my mentor, Valeria, my Eli cohort, and Urka as well for providing funding. Thank you very much.